All right, today we're going to work on how to evaluate logarithms. All right, so yesterday we spent time changing the forms from exponential to logarithmic and vice versa. What we're going to look at is how to evaluate this. So the first way I'm going to show you how to evaluate this is to rewrite it in exponential form. So first I'm going to make this an equation. I'm going to say this is equal to y, and my goal is to figure out what this y is. So if I rewrite this as an exponent, so remembering that the definition, if we have log base b of some number a equals c, then this is equivalent to the equation b to the c power is equal to a. All right, so if I rewrite this using that exponential equivalent equation, it would be 2 to the y power is equal to 8. And then thinking about what we did earlier this week, rewrite these so they have the same base. So I know that 2 to the third power is equal to 8. So if 2 to the y is equal to 2 to the third, now since they have the same base, that means that I can figure out what y is equal to, and y is going to be equal to 3. All right, so that's kind of the long way to do one of these problems. Here's a shortcut so we don't have to always write it out. Our big idea is going to be to make this into some base 2. I want those to agree. So then I could rewrite this of log base 2 of 2 to the third power. And then once we get those bases the same, what one of my properties is going to tell us that I'll write down here in a second, that is going to be equal to 3. All right, and we're going to learn some more properties next week and make a little bit more sense of why this is. But if I can make these bases the same, just like I did here, then the solution is going to be that exponent. All right, so here's kind of like an identity property of log. If I have log base b of b to any power, so those bases are the same, so let's make this the x power, then that is going to be equal to x. So when we're evaluating logarithms, again, this is really what's happening. So we could rewrite it as an exponential, but to kind of take one step out of it, if we can rewrite whatever number is right here as that same base, then our answer is going to be whatever the exponent is. All right, so we're going to look at a couple more, and then your job for today is to practice some of these on the practice problems in Canvas. So if we look at letter A, we have 2 for our base. So we're going to rewrite 16 as base 2. So I know that 16 is 2 times 8. And hopefully remember that 8 is 2 to the third. So 2 times 2 to the third, 16 is going to be 2 to the fourth. So again, once I get the base of my logarithm and the base of my, what I've turned 16 into, once I get those the same, the answer is just going to be the exponent, which is 4. All right, and again, there's nothing wrong with, if you want to do this the long way, set it equal to any letter you want, and then the equation that we're going to solve is 2 to the y has to be 16, and 2 to the fourth is 16. All right, I'm looking at B. This one, in my opinion, is a little bit harder because the base is bigger than this. But let's think about what we have to do to 9 to turn it into 3. The square root of 9 is 3, and another way to write the square root is 9 to the 1/2 power. So when I rewrite this, this would be log base 9 of 9 to the 1/2. So therefore, I've got those bases to be the same. This thing's going to evaluate and leave us with 1/2 for letter B. Again, if you don't want to use that method, you can always go back into that exponential form, and this would be 9 to the y power has to equal 3, and the square root of 9 is 3. So 1/2 is our exponent. All right, and 1/2 is what this evaluates to. All right, C looks a little bit different because it doesn't have the base. Remember, if there isn't a base there and it is the word log, that means it is base 10. All right, so I want to rewrite 100 as a power of 10. So this would be log base 10 of 100 is 10 squared. So now that I've got those bases the same, I know that the answer to this is going to be 2. All right, or if I wanted to rewrite this in exponential form, it's going to be 10 to what power is equal to 100, and that power is 2. All right, one more here on the screen. We've got log base 4 and 1/16. So I've got to make this 1 over 16 4 to some power. So 4 to the second power is just regular 16, right? 4 squared is 16. So if I want to make it 1 over 16, then that's going to be 4 to the negative second power is equal to 1 over 16. So when I'm looking at this setup here, we've got log base 4 of 4 to the negative second. So then this is going to evaluate and give me a solution of negative 2. All right, or again, if you prefer writing it as an exponential, 4 to what power is 1 over 16, and we solve that equation like we've been working on for the last few days. All right, we're going to do a few more, and then you have some practice of these same types of strategies to do on your own. All right, E looks a little bit different because of the fact that it's ln. Remember, ln is called a natural log. It is just log base E. So this letter E is the same thing as log base E of E to the 5th. So again, if I want to write it as an exponential, I put my variable over here and rewrite it as E to the Y has to equal E to the 5th. And because they have the same base, now I know that y has to be 5. All right, or again, if we can get these to be the same base, our solution's always going to be the exponent. All right, f is also missing the base, but this one's different. It's not ln, it's log. This is log base 10. This is a common log rather than a natural log. All right, here I have a decimal. If I said this decimal, I know it's tempting to just say 0.01. If I said it, it's 1/100th. Like you learned how to say them in elementary school, and then we lose some of our math language, unfortunately. Another way to say this, I know that when you look at it, you're probably thinking 0.01, but that's also 100th. So that's the same as 1/100th. So 1 divided by 100. All right, so this is what we're evaluating. Again, if we want to do it in exponential equation form, it would be 10 to what power is equal to 1 over 100. Or again, we're just trying to get this as a base 10. And what do I think about? If I have 10 and 100, hopefully you're thinking about squared. So we know that 10 squared is 100. So to get 1 over 100, we need to make the exponent negative. So another way to write this would be log base 10 of 10 to the negative second, which means this one's going to evaluate to negative 2 for our solution here. All right, we've got 2 more to go here. We've got log base 7 of 7. So what you think about is 7 is just 7 to the first. They are already the same base. So this is going to be equal to 1. All right. If we wanted to do it with exponentials, hopefully that makes it 7 to what power equals 7? That's going to be 1. And then our last one here is log base 12 equals to 1. So we're going to rewrite 1 as 12 to some power. All right, remember any number to the 0 power is equal to 1. So there's another way to write h would be log base 12 of 12 to the 0 power. So then our answer for h is going to be 0. All right, so here's just a small sample of how to evaluate these. All right, again, if you like going into exponential form like I did on this one, go for it. But if you can get the bases the same, then remember that your exponent is going to be what the log evaluates to. So give those problems a try on Canvas. Check in conferences if you need any help, and have a great day.